Good evening, everybody, and welcome to our lecture tonight, which relates to sprinkler systems and water mist systems. Couple of housekeeping things first. Fire exits in the event of the fire alarm activating. Fire exit behind you that we all came in through. There's a fire exit off here to my left, to your right. In the event of an evacuation, follow me. I'll be going out and directing you outside. So it's dark outside, it's wet, but pay attention to the steps immediately outside the door when you step outside. There's steps upwards into the courtyard. We're webcasting tonight, so welcome to everybody who's online watching us, everybody from Limerick and Cork, Thomond region, to our colleagues in Poland who are watching. And anybody who's got any questions, you can email me at mpl882@yahoo.ie, and I will collect the emails of any questions for the speaker and compile them, and we'll try and ask the speaker at the end of the talk if there is any questions from anybody online who's asking. Draw attention to everybody to turn off their mobile phones. The speaker will welcome questions during the presentation if you do have questions. The presentation will probably last about an hour. It may last longer. But if you do have questions, please feel free to ask them during the presentation as well. Next week, next Friday here in Engineers Ireland, there is a fire safety seminar organised with the University of Ulster with Professor Ali Naji. And it's a workshop to do with structural fire engineering and fire cert issues to do with the ability of University of Ulster for fire testing and issues related to fire safety testing and fire safety structural engineering. For anybody who wants to attend, you can go to the Engineers Ireland website and register for your attendance. Attendance is free, but you do need to pre-register in terms of booking a seat. So there's not a lot of time left for doing so, but if you do want to do it, go to Engineers Ireland's website and register online there. Our speaker tonight is Gary Howe from Howe or Howe, Gary? Howe? Yep. Very good. Gary has many years of experience, both practical experience and design experience and inspecting experience in relation to sprinkler systems and water mist systems from working now with Zurich Fire Protection. So without further ado, I'd like to give the floor to Gary and welcome him to Engineers Ireland.
Good evening, everyone, and thank you for the opportunity to provide a presentation on sprinklers and specifically issues around water mist. This presentation comes really from my personal involvement in a multitude of projects related to water mist in the last 8 years. Road tunnels, industrial oil cookers, combustion turbines, hotels, offices, machinery spaces, high-rise buildings. So it really comes based on my practical experience in the field, and I welcome some questions as we go along. Now, my involvement with water mist is embedded through a number of working groups, as you can see on the screen there, both in Britain and in Europe as well. I sit on those working group committees, the European one being 14972. I also sit on the NFPA 750 committee for the global water mist standard, and I'll cover some aspects of that today as well. And we've also, within the Institution of Fire Engineers, just launched a new SIG group, special interest group, around fixed fire protection as well, to raise the profile of fixed fire protection and provide some thought leadership through the Institution of Fire Engineers as to the future of fixed fire protection. And I'm also a regular contributor to the IFE journal, and if you are a member of the IFE, there will be an article in this month's journal on this very subject. So, challenges. There are many challenges related to water mist, and we've found these really the hard way in the field, by coming across them, dealing with them, and one of the big issues I really want to start off with is around competency. within the sprinkler market, we have a long history of installations, over 100 years of experience in the sprinkler market, whereas the land-based water mist market is a more immature market. And because it is an immature market, the quality of installation on site can often not be to the required standard. It's one of the big issues I find on site, the lack of competency of installers, me having to personally snag their work and highlight risk improvement actions. And also because in the land-based market, it is relatively immature, designers also as well, also their designs really need careful scrutiny. So what I do in Zurich in our team is we undertake a detailed design review of all our water mist projects. So we don't just say it's been designed by contractor A, it must be okay. We undertake a detailed design review of hydraulic calculation, pipe sizes, pipe work routes, dimensioning, so we can be assured that the design is correct, and that's something I would really encourage. And one of the things we find within Zurich in the field is that the fire and rescue officers and the building control officers do not really have a great deal of experience in the field of water mist. And as such, because of that lack of experience and deep involvement, it appears that they are signing off systems, accepting systems that are below par and may have some fundamental flaws. And I'll go on to show you some case studies where we've highlighted major issues with systems which have been signed off by an authority having jurisdiction and not knowing that there are actually issues with the system. And buyers can be often attracted by the lower cost of water mist, and there are some really great examples of where water mist is a really good tool in the toolbox of the fire protection engineer, and I've come across many such examples and recommended water mist. But also we also have to just be careful, as a note of caution there, that buyers can often be attracted by the lower price than sprinklers, but are we comparing apples with apples? And often we're not. We're comparing apples with pears, and often, especially for the land-based market, we can be looking at water mist being promoted to us as being cheaper than sprinklers. But for example, one simple example is it may not cover 100% of the building. So quite clearly the water mist system is going to be cheaper than the conventional sprinkler system if we're not covering the complete all areas of the building. And I'll give you a good case study where that's highlighted. And budgets have been a big driver also for water mist. Water mist being promoted as an alternative to sprinklers. And as I said, it can be a good solution in many applications. But fire engineers, in my experience, do lack the competency and knowledge to adequately understand the scope and use of water mist. Only recently I had a fire engineer from a very well-known consultancy recommend in my presence water mist for a 25-metre tall warehouse containing hanging garments. And there is no such test protocol for such application. And it was on a wing and a prayer that particular consultant suggested to me that actually this would be a good solution instead of sprinklers. And so we have to be careful. It is a specific application solution. We have fire engineers, fire consultants out there recommending water mist, but remember it needs to be backed up by independent test data for the application in which it's going to be used. And I'll cover that in a bit more detail. And we're seeing value engineering becoming more and more to the fore now, especially in the sprinkler market. I'm working on a project now for schools in the UK. We're seeing less and less sprinklered schools in the UK under the current government, and it's something we're quite passionate about in Zurich, to say that actually we're seeing lots and lots of value engineering in the UK construction market, where actually fixed fire protection is being eliminated purely on a budgetary basis. So it's something that we're seeing, well, can we use water mist instead? Well, possibly, but let's examine that a bit more details later on. And there's a big long list here of design issues that we come across. And I think one of the biggest issues that I find and troubles me personally is the use of non-listed components. We still have some suppliers of water mist systems installing today in 2018 non-listed third-party accredited components. This wouldn't happen in the sprinkler market. You'd have an LPCB, FM, UL listed sprinkler head. But that doesn't always happen in the water mist market. There are some very good manufacturers who supply third-party accredited components. It doesn't always apply to everybody in the field. So it's, as a note of caution, if you're involved in a water mist project, check the validity and the accreditation of components, because, and I'll give you some practical examples where we've got some non-listed components that have been installed as in this year. And one of the other key areas is the absence of independent fire test data. Often the suppliers of these systems cannot verify that the water mist system is fit for purpose. It should be backed up by independent fire test data for each and every application in a building. And often that lack of independent fire test data is conveniently forgot about or not demonstrated by the installer. And there can often be many, many unprotected areas in, I come across buildings such as schools where we've got water mist, but there's lots of unprotected areas. So it's sold as a property protection system, but in fact, all it really is a life safety system. So it's important to understand what the objective of that water mist system, what are you trying to achieve? If it's a partial system, it cannot be a property protection system. It can only be there for means of escape, for prevention of flashover, lowering compartment temperatures. So be careful, be tenacious, and ask what the objective of that system is. And we also have another challenge around O-rings. It's a lesson that the sprinkler industry learned, a hard lesson that the sprinkler industry learned a few years ago about O-rings in sprinklers, where required elevated pressures for the sprinkler heads to work. And when you send them away to a test lab to be tested, they will generally fail and may require 6 or 7 bar to release the seating. Well, the water mist industry and some manufacturers are now repeating the mistakes of old and selling O-rings within their heads. So the lesson hasn't been learned. So that's really, really an important one. And also, one of the big issues we have within the water mist system at the bottom there is around challenging architectural features. If you look at the sprinkler rules, there's clear guidance about what we do about slope ceiling, obstructions, egg crate ceilings, beams and bays, circular ducting, rectangular ducting. How all of these challenge architectural features we commonly find in buildings. When I come across water mist projects, I find in design manuals no reference to how we deal with all these challenges. It can often just be guesswork as to how we deal with those. So there's no real history or provenance about dealing with architectural challenging features in the building. So if we've got egg crate ceilings, we've got slope ceilings, we've got obstructions in the way, be challenging and ask, where is the design information to support what do I do with my water mist nozzles? And moving on to installation, again, competency of installers is a key concern for insurers, but also, as with the wider construction industry, absence of project management. We often find that these systems are simply given to a subcontractor, or a subcontractor subcontracts to someone else, and there is no verification of that installation on site by the supplier or the installer or a third party. So they're simply left to their own devices to install the system. And guess what? It's not surprising we find problems on site and I go along and snag and find multiple issues and leave the client with a big long list of risk improvement actions because that system is simply not fit for purpose. I shouldn't have to police the industry, but I'm doing that quite often. And one of the big areas to be really, really careful of and to watch out for is witness and discharge testing. The vast majority of these systems are simply installed and never proven or commissioned correctly. I'll give you some great case studies later on where I found issues where the customer relied on a piece of paper a certificate to say that system was fit for purpose, and in most cases it isn't. I wrote an article for the IFE Journal in 2015 giving my experience of witness and discharge testing of water mist systems. 90% failure rate when tested. 90%. Okay, and I'll give you some examples of that. And we come across buildings, large buildings, high-rise buildings, where there are complex cause and effects matrices associated with that sequence of events. And I asked the question, where is the interaction between the water mist system, bringing down the lifts, closing the doors, shutting off the gas valves? And it's my experience that none of that interaction between the mechanical side of the project, the water mist side, and the electrical side and the sequence of events ever gets proven and tested. And I think it's a wider issue within the construction industry that we've got systems out there where we've not got coordination between contractors and lines of responsibility. And we're also finding water mist being installed in areas where there's simply no test protocols exist, and the installer has simply ignored the fact there is no test protocol to underpin and support that water mist installation. They've gone ahead and done it. My classic case of the hanging garment storage, 25 metres high. There is no way water mist would have ever worked in that environment. The fire consultant was going to go ahead with that if I hadn't just pulled his braces back a bit. So it's our opinion within Zurich that because most of these systems, and I'm really focusing now on the land-based market because this is where water mist is moving into the traditional domain of sprinklers, the marine market of machinery spaces, combustion turbines, etc. is well established and a proven history for water mist. However, because the systems are predominantly partial in nature, it's important to be clear that these systems are predominantly and really installed for life safety purposes. And they're there for these reasons here. And it's important that we challenge designers around what the objective of that system is. What are you trying to achieve? And in most cases, it's around life safety. Now, that's a laudable argument, a laudable objective. But as an insurer, we like to look wider and say, we've got a life safety system, but we also want the building to stand after a fire. We don't want sacrificial buildings. We want to protect, we want a resilient environment where it goes beyond life safety. And one of the real key challenges is when we have design meetings is around the discussion with consultants and fire engineers around these two sections on the left. The architect will deal with the architectural requirements of the building, the form and function. The fire engineer, fire consultant and the fire officer building control possibly, will deal with the legislative life safety requirements, but that's where everything stops. Within Zurich, we will also say that the reason this chart, which comes from BS 7974, asks you to consider the business and insurance and business resilience of the project as well. So when we look at a project, we look at all three strands about achieving all three elements of those. And it's important that we build a resilient built environment and we go beyond just life safety. So water mist may be acceptable, but it needs to be supported and underpinned by realistic fire testing and data. And by that I mean independent fire test data. Even in 2018 we're having water mist manufacturers and suppliers undertaking their own testing. I can still now today hire the facility of a lab, a third-party accredited lab. I can hire the facility, I can undertake my fire test there, and the lab has no involvement whatsoever with that fire test. I can design the fire test, I can construct the fire test, I can decide what the pass and fail criteria is for that fire test, and at the end of that process I get a nice shiny document with the lab's name splattered all over that document. And some of our Zurich customers are getting those documents thinking, great, This has been tested at that lab A. It's been tested at that lab, not by that lab. So it's really important that you challenge any fire test protocols that come across your desk and understand what the provenance of those are. I'm too smart to be caught out by things like that, but many people in the industry are being caught out by a nice shiny badge of a well-known lab splattered all over a test document. Be tenacious and ask the question, who designed the test, who decided the pass-fail criteria? And not all water mist systems are equal. It is a very mixed bag. There are some very good manufacturers out there and suppliers, and there are some very poor ones. It's very much a case of the good, the bad and the ugly. So it is a bespoke solution, and it's important to understand that water mist needs representative fire test data for the application in which it's being used. It's common for me to be given fire test data for one application where genuinely the system's gone through robust testing by an independent lab, and then it being used for something else, hoping that we wouldn't recognise that, or hoping that we wouldn't be caught out by that. So it's really important that if it's tested for A, it's actually used in A and not used in B. And components are generally not interchangeable. You can't simply swap out one manufacturer's head for another manufacturer's head, because the spacing, the spray pattern and the testing are both different. So it's important to remember that components are generally not interchangeable. And because the applications are specific, often they're not suitable for property protection as well. So it's understanding whether that application is suitable. Now, there's a list of standards on the board there, and it's common for us to receive design or specifications with a list of standards. Well, which one matters? Well, they all matter in their own way, but the most important thing to remember is NFPA 750. Have a look at 1.1 and have a look at the red box. Because you don't have to read NFPA 750. The most important part of that is the scope and reliance placed on listed water mist equipment and demonstrate performance in fire testing as part of a listed process. So there's two important parts to there, and often the projects I see, they may have only done one element. They might have done the fire testing, but they might not have also done the listing and testing of the components. So some of the better manufacturers will actually have done both parts. So if you're going to accept a system, you want the representative fire test data for the fire test, and also you want the representative data and component testing and listing and certification. So it's like a marriage of two people. You've got to have both elements, and be careful because sometimes you'll only get just the one. Now we're moving from the traditional domain of the machinery space era, from the marine environment, where there are well-established IMO protocols, for example, and where we can be confident that water mist within the bounds of the fire test certification for ships' cabins, corridors, machinery spaces, combustion, diesel generators. We know the local application, we know the history of that, but we're now moving over to the light hazard, ordinary hazard occupancy. And this is where we need to be careful where we move to the land-based applications. And again, I'll support some of my arguments with some case studies. So what do I have to do as a job? My job in Zurich is to support underwriters and assess systems, fire protection systems, all forms of fire protection systems. And those are the three questions I must be able to answer with confidence when I do any of my site assessments. I did a site assessment today in Dublin, and it equally applies to that site as well. Is it in service? Is the pump switched on? Is there fuel in the tank? Is there water in the tank? Will it work? By undertaking practical testing of it and also analysis of the design. And this 3-stage process is really useful to us. It verifies the effectiveness of that system. And we do that by undertaking this 5-step process. So all of the major projects we work on, we undertake this 5-step process for our underwriters. So we go through a detailed design, installation, specification, on-site verification, and checking site plans, hydraulic calculations. That way, if we go through that 5-step process, we can, with confidence at the end of that process, come up with an assessment, analysis, and an opinion of that risk. Too often we're finding in the field that fire officers, building control officers and fire engineers are simply relying on a piece of paper from an installer and going, thank you very much, I've got a commissioning certificate. Well, we have a saying in Zurich, the certificates don't put out fires. And too often the industry is relying on pieces of paper as a means of validating designs and installations. It's our opinion that that simply isn't good enough, and it lulls you into a false sense of security. And that's why we don't accept pieces of paper as means of verification of system designs. So, is it in service? Well, that's quite simple really, by having boots on the ground, checking the valves open. Every year when I do site assessments, I'll find valves closed. Pump switched off is the power. Impaired systems. On water mist systems, I will find solenoids disconnected from high pressure cylinder banks, just hanging in midair. Water in the tank, I'll physically get up there and check we've got water in the tank. And if it's the town's main system, have we tested the supply to make sure we're getting the adequate pressures and flows? Here's one example of a water mist system that I went to see in a high-rise building. So, is it in service? Don't know if everyone can see the picture very well, but it's a picture of a valve that's closed. How did I find that? By looking above numerous ceilings to see whether actually the system was actually operational. I shouldn't have had to do that. That system had been signed off by 3 other people before I reached site. But it goes to prove checking is it in service is a fundamental part of our role. And clearly it wasn't in service. If there had been a fire, we'd have had a major fire in the high-rise building. So it shows a lack somewhere, a lack of competency by somebody in the process. And this is not an uncommon issue to find. It happens more than we think.
Gary, are valves like that common in water mist systems?
And some manufacturers' valves are like that. Obviously, each manufacturer can have different types of valve. That's one.
What I'm meaning is valves downstream of your
very common.
An alarm valve.
Yeah, very much so. Yeah, very much so. So this would be like a typical valve on a floor isolation valve, like you'd find on the sprinkler system. So this, in this case, served a particular area of the building. And you can see it's a non-monitored valve. So it makes it even more important if it's non-monitored. But don't take it as read, even if it's a monitored valve. I will actually go to the valve and close it and open it and make sure we get a signal at the fire panel. And often there's been a miscommunication between the mechanical side of the project and the electrical side, where the fire detection contractor's done their bit and the mechanical guy's done their bit, and they haven't talked to each other. So actually go a bit further and actually get that valve to be closed and make sure you get a signal at the fire panel. Another common issue, anybody spot the mistake? Yeah, a few nods in the audience. The protective rubber cap is still on the frangible bulb. Yeah? System had been signed off by the installer as fit for purpose. And it comes down to the insurance fire protection engineer to walk around the building and find those. It's a bit embarrassing for the installer, but it shouldn't be something we should find on site. It shows a lack of robust project management, sign-off and checking of the system. And there was more than one in that particular building. So, goes back to my previous point. If you'd have relied on a piece of paper and not looked around the building, you wouldn't have found this. What about that? Can anyone see what the issue is with that picture? Yeah? obstructed nozzle. Yeah? So you can see that 50% of that water mist is just simply going to hit the side of that insulated pipework and be ineffective in a machinery space. Again, it was found due to a robust check on site of going in every single plant room, every single ceiling void, and finding these things on site and getting them rectified. Again, I stress the point, the installer should have dealt with this issue. It shouldn't be up to the authority having jurisdiction, in this case me, the insurer, finding these things. So don't trust the installer always to get it right. And by the way, the other crime in that one on there is that the pipework in the machinery plant room, you could have swung from it as well, because it was like a washing line inside the machinery space as well. And when you grabbed hold of the pipework, it made a tune as you pulled it. So will it work? And it's really important. And this applies, is it in service, will it work? Equally applies to all forms of fire protection, but I'm predominantly concentrating here on sprinklers and water mist. Is there a maintenance contract in place? Are the pumps being weekly tested if it's a pump-based system? Have you got evidence to support that? Are the pumps achieving rated duty? Well, I still find the service engineer filling in his service and maintenance sheet with figures that are made up. When I've gone to actually physically flow test the pump, my figures and their figures from the last service do not match. So it's important that those tests of the pumps, are they making the requirements, the hydraulic demand checked? And what about pre-action systems where we've got detection and we've got mechanical deluge or discharge of water? Can you be confident that when that detector goes off, it discharges water into that space? And in most cases, the detection contractor will have done their bit, the water mist contractor will have done their bit, but they wouldn't have joined together to actually prove both elements talk to each other. And it's one of the big failings we find in the field. And again, the cause and effects matrix. If you have one that says the conveyors stop, the fire doors come down, the lifts stop, have you proven it? Here's an example of a test of an underground car park, multiple levels of underground car park. The customer had a nice shiny certificate to say that the system had been signed off by the installer. My question was, on a dry system, how long did it take you to get water from the valve set to the hydraulically most remote point of the installation? And the answer was, we haven't tested it. So we're in a high challenge, high fire load underground car park with difficult firefighting access and egress, and the contractor hasn't proven the system is fit for purpose. So I asked the important question, well, I need to test it. I want that proven. And when it was proven, most of the systems actually failed their water delivery discharge times to get water to the point of delivery. I'm there late at night testing this system, and some of them took over 3.5 minutes to deliver water to the hydraulically most remote point. So bear in mind, we could have a car on fire and we're waiting 3.5 minutes for water. This system is currently being modified by the installer who have admitted fault on this system.
In a system like that, what would the typical cause of that be? Is it just too long pipe runs, or?
Yeah, generally speaking, it could be one of two things. It could be too much air sitting on top of the valve, the air water, so where we put too much air to stop the valve tripping, or more commonly, it'd be a mistake in the design, the volume of pipework is too big. So the volume of air within the pipework to expunge means it's taken too long. So if you come across dry systems, even on sprinkler systems, always ask the question, how long did it take water to get out of the most remote point? Try and do the test. If you're not comfortable doing the test, supervise the test with a competent contractor with your stopwatch and make sure you get water delivery within the allocated time. And it's one of the areas where dry systems in all forms of fire protection commonly fail. And within the sprinkler world, it's generally 60 seconds, you're waiting. The worst one I ever had took 14 minutes to get water out of the pipework. I might as well call that a failure, eh? And other things we find on site as well. Can anyone spot the issue there? To a beam, yeah. We've got well-established rules within the sprinkler world on how to design systems. I would say, looking at that, I don't think that's got much of a chance of really delivering and a suitable spray pattern, has it? Yeah, above a ceiling. I think
Sorry, Gary, is that plastic pipe work?
that is a very good spot, and you're dead right. And it's non-approved, non-listed, cheap and cheerful plastic pipe. And thanks for picking that up, because I'll cover that in a bit more detail. Now, this is an interesting case, this one. This one resulted in a very large insurable claim in a very expensive block of apartments in London, where a water mist system activated due to a fire. But what happened is the contractor, rather than using the listed certified manufacturer specified flexible connection, decided to buy their own version because they were cheaper. And as a result, in the event of it going from standing pressure 15, 20 bar up to over 100 bar, 75 flexible connections decided to come apart and left an insurer with a very large water damage claim. So what we did was, as part of our forensic investigation, we took the flexible connections and a sample of them to a specialist test lab, and we tested them under real world conditions. Can you see what happened when we ramped up the pressure? Leaked. Yeah? And that was down to them using non-listed, non-approved pneumatic hoses on a high pressure water mist system. Now, you may shake your head and think, oh, well, he's giving me a one-off catastrophic view, but actually I'm not. This is a common issue within the industry of non-listed, non-effective components.
Was the issue there that the pressure rating of the pipe was wrong, or was it what?
Well, basically the issue was they weren't listed or tested for that intended application to work at 140 bar. And the reason is they were rated to work at a high pressure, but what happens is they're pneumatic hoses. So if you can imagine a hose with another hose inside, on the outside you had hundreds of tiny pinprick holes. So when it overpressurized, the idea was that the outer sheath discharged the overpressure through the holes in the outer sheath. So the air discharged out. But that's okay if you're dealing with air, but we're dealing with water. So the water had a route to Rome by escaping from the pipework. So these were above the plasterboard ceiling. Now, we didn't do the design review on this. This system was installed before we got involved with it. But it just goes to highlight really some of the key challenges and things to look out for, especially around flexible connections and components. And we proved, and we had to prove that actually the installer was at fault by simply going to a supplier of pneumatic hoses that you could use on a tractor or anything else and using that.
Gary, under UK law, would there be criminal sanctions against the contractor who exchanged a faulty hose for a proper hose?
The honest answer is I don't really know, but what I can say in this case is that the main contractor responsible for the installation decided to go ahead and undertake all the remedial action themselves at their cost. So I think in some ways that's perhaps an omission, isn't it, that their system wasn't fit for purpose. And it's common also to come across water mist nozzles that need check-in and verification around listing and certification. When you come across them in, for example, in hotels like this, and also in the same hotel, another form of nozzle that may warrant a further examination and check to see whether actually they are suitable and fit for purpose. What we've done at NFPA 750 is we've said we've reduced the time down, and we've suggested that that goes forward to NFPA 25, the maintenance section of NFPA to say that if you come across these in the field and you're unsure of their effectiveness, what you can do is ask the client or suggest to the client that you take a sample of those heads away for testing to an independent fire test lab. So, for example, the BRE at Watford will have a means of testing heads. So if you want the confidence that some heads are actually fit for purpose, both from a will they work, and also you can then ask for the independent fire test data. So I do this quite commonly. I ask for testing. So typically after, if they've been in the field 5 years, or I don't know the provenance or history of those nozzles, or I've got no data to support them, you can ask for a sample to be sent away for testing. And there, Roland, there's your plastic pipe on the same installation. So thanks for picking that up. And again, an example of one of our clients where a system has been installed which wouldn't meet any known standard. Unfortunately, because there was a slight issue with the video here, one of the things we do very much pride ourselves on Zurich is, will it work? And I do a lot of industrial oil cookers, big large fryers, which would typically be about the length of this room, for crisp manufacturers, donut manufacturers, pancakes, bread, and also bread for travelling ovens. And one of the things we've found, one of the most common failures we've found is when we find failure when the system gets discharge tested. And on all of our fryers and ovens, we will actually undertake full discharge testing to check the functionality of the system, run the system for 5 to 10 minutes and make sure all the nozzles are clear, we've got a correct spray pattern, and that gives you one example there where we will do that on all new projects. So I'd really encourage you, if you come across water mist systems, to make sure that you can get some, if you can't be boots on the ground, get the client to video a test for you and demonstrate to you that that system will actually function when intended. I have done this on multiple occasions and have had nozzles with no water come out of them, and I've had pipework blow apart. I've had one industrial oil cooker project which took 4 attempts for it to get it right. And we see lots of these in the field that have not been tested. The will it work bit is really, really important.
Gary, what's the discharge time typically for travelling ovens?
It depends if it's a high pressure system or a pump based system. So normally for a pump based system we'd ask for a 30-minute duration. For the stored pressure you're normally looking at a 10-minute supply. And another example is a sauna. It's a very expensive sauna in someone's house as well, where they've got water mist within that environment. Again, we test every single sauna system we come across. And again, we've had multiple failures in this environment. Quite a simple water mist system off the town's mains, where we've got insufficient pressures and flows and blocked nozzles as well. And one of the other things I've done this year, I've tested too, this is a major road tunnel in the northeast of England. And what I did, we went there with a colleague at midnight and tested 45 metres of the water mist system. Actually got them to fully discharge. We closed the road tunnel and discharged the water mist system to make sure it was fit for purpose. In this case, everything worked absolutely spot on, just as is intended. So we do have some good news stories, but it gives us confidence as engineers that we've actually proven the system is fit for purpose in anger.
Does this system have open heads?
Open heads, deluge system. So this system is a little bit unusual insofar as it's a manual system, but there is linear heat cable in the tunnel.
Solenoid valves or something?
Yeah, that's it. Solenoid valves down there. Exactly. Yeah. And one of the other things that's really important to do on this is a system where I asked the installer to undertake testing of the pumps. So we'll go actually check the pressure and flow of each of the pumps. In this particular case, the pumps delivered the correct pressures and flows that was needed, but it was important as part of the verification that the installer could show me on the flow meter. We'll run the pumps through various stages and make sure we got exactly what the system was intended to provide. So try and get on site and verify that the pump set delivers the correct pressures and flows, and be there, be challenging, be tenacious and check them. This is a site. I'm sorry I can't show you the video on this one, but this is a deluge system where you've got triple IR flame detectors operating a solenoid valve, and this is on a waste to energy risk where we've got shredded wood biomass on a waste to energy plant where I did a full discharge test to make sure the system was fit for purpose. And it was a good example of actually proving that system delivering water for at least 10 minutes to make sure the pumps, the spray pattern and the system operated as intended. So that's the will it work bit. How do we verify the system design? So I'll give you some tips and hints on how to do that when you come across these in the field. Now you can look at BS 8489 part 1. And it's important around when you're looking at design, just to bear in mind at the moment within 8489, there are only a limited selection of occupancies where test protocols exist. So it's important when you come across a project in a commercial industrial environment that you cross-map the application in which the water mist system is intended or is fitted with the relevant British Standard document to say, for example, where is it listed, where is the test protocol, and 8489 part 1 is a good starting point.
Those would mostly, if it was sprinklers, be ordinary hazards, would they?
They would, light or ordinary hazard, yeah. But there would be some slight exceptions which I'll cover. And if you're dealing with residential, which I suspect some of you are as well, so within the residential and domestic market, there's again, depending whether you're dealing with domestic or residential, there are some specific applications and occupancies. And again, it's to cross-map your building or proposed building with the list of occupancies on there to make sure you've got a fit. You're fitting a square peg into a square hole. Now, a useful tool if you are undertaking a design review of a water mist system is to download this document. This document is available from the Risk Authority, which you can put into a search engine. And what it does is there's 3 different types of this questionnaire: local application and building protection one. And what you can do is give that to the installer or the designer, and what that will do, that will ask them to complete the questionnaire on your behalf. And it goes through all the kind of questions and issues that I'm raising within this presentation and challenges the designer or installer of the system to give you all of the pertinent information you need in order to make an informed decision about that water mist system. So I strongly encourage you to use these documents, and they're very, very useful. I use them a lot because it asks the installer to give you information about the components, about the design, about the calculations, about the pipe sizes, about the fire test protocols. So in order to fully evaluate water mist systems and all forms of fire protection system, Zurich has this 4-stage simple approach. And it's a tool I use that I think you could also use to properly evaluate water mist systems. And what it does is it asks you to go through 4 simple steps. Has the system been tested by a recognised independent third-party accredited laboratory? Is it underpinned in the bottom left-hand corner by a recognised standard, BS, EN or standard? Is there a test protocol available to verify for both the components and the fire test? And have you got the manufacturer's guidelines, design, installation, operation manual? So you cannot verify a system without that design manual, because if it says in the design manual the spacings are 2.5 metres by 2.5 metres, you cannot go on site without that information, because you need a tape measure and that information to verify and cross-map from the design manual to what the contractor's on site. And I can find systems on site where the spacings are at 2.5 by 2.5 and the installers put them at 4 by 4, totally invalidating the fire test and the design manual. So this four-stage process, I'll just elaborate on that now. So what's a recognised testing laboratory? It's evaluated by a third-party accredited laboratory. So it's a UCAS accredited or third-party independent laboratory, such as the BRE, the UL, for example, in the US. And have they got accreditation to undertake testing for water mist within their scope? So that's the first thing to check. Is there a recognised code? A recognised code for assessment purposes, such as NFPA 750, 8489? Have you got the manufacturer's guidelines, and where is the evidence to support the test protocols? We use this tool all the time, and it's really useful because it forces the designer, the installer, to give you the answers to each of those questions. If you haven't got answers to each of those questions, it's a system you cannot accept because sufficient evidence hasn't been provided. I'd like to just share with you some case studies and to put this into perspective around design, will it work, and is it in service? So 3 simple case studies. We get asked to accept systems quite a bit for timber saunas. We've had a lot of fires in timber saunas over the years where we've lost complete leisure clubs, sports centres, hotels, even houses, private houses. And we get approached with systems of stored pressure systems, a variety of systems from different manufacturers. And we've actually had failures of water mist systems in this particular application. And you can see from the photograph, in less than 5 minutes, you can get to flashover in a timber sauna. This is a test that I undertook at a fire test lab to see actually what would happen in a timber sauna. How quick could we get to flashover? And here's an example on the right of one of my test pass-fail criteria for my fire test was that the fire mustn't break out of the sauna compartment itself. And that was the only damage to the sauna when the water mist system activated. So I ripped apart the sauna, took it apart, analysed the damage, and that's the only damage we had. So it proves it's an effective solution for a small combustible risk like that. However, how did we get to that point? We got to that point by undertaking fire testing at an approved lab by the fire test lab, using listed components that had been fire tested to a recognised global standard, in this case CEN 14972, and we also had detailed manufacturer's guidance. Now when I get water mist systems for these type of applications, I go through this 4-stage process, and at the moment there is no manufacturer in the world, apart from one, who have undertaken this form of testing for combustible saunas. But they are still being installed and sold, regardless of the fact that there isn't evidence to support their use within saunas. And there's loads of major chains where systems have been installed that cannot stand the scrutiny of this 4-stage process.
Who is the contractor, the supplier that you found?
So the one supplier we work with in this case, and we have no tie-in with them, it's just that they're the ones who wanted to fund the project. There's a company called Flamefast in the UK, and they funded the fire testing to enable them to achieve a recognised solution. And there was the solution. And the reason the boxes are green is because the boxes have been ticked as the answer is yes. So we have the Danish Fire Labs. So we have an independent accredited third-party test. We have a global standard linked to also the SEN standard. We have fire test protocol from the Danish Fire Lab and component standards. And we also have the manufacturer's instruction. So having gone through that rigorous 4-stage process, I can be confident that that system is fit for purpose. The evidence has been provided, and also I need to back that up by an on-site test as well to make sure they will actually work in anger.
In terms of the Danish testing, what would they have tested? Is there sort of a typical sauna setup within
Yeah, so that's a really good question. So what happened was in that case is we developed a reference test. We used a single K80-141 sprinkler test ahead, undertook a test in a sauna that measured 3 by 2 by 2, and then undertook fire testing of that to see. So we had some base data for a sprinkler, and then repeated that test multiple times with a water mist head to see if it was equal to or better than the sprinkler head.
Would that put limits on the size of that
Yeah,
it could go up to? And how would that
exactly.
work?
So it's limited at the moment. The fire test is specifically limited to 3 by 2 by 2 meters high. So if you was to have a sauna that was beyond that, this test protocol wouldn't apply. So if it's less than, but you're right, that's a very good point. You can't go beyond it.
If it's bigger, you got to retest.
Retest, yeah. This is an interesting case. We of an industrial oil cooker, a very good application for water mist, donut fryer. Just remember have a look at the length and width of the fryer. Try and remember the number and the amount of oil that's in that fryer. Okay, that isn't a donut fryer on there, but that's just to give you an idea of the sort of scale of the fryer that was on site. So, I asked my questions. First question, can I have the representative fire test data? And this is a system that's already been installed. So it gives a good example of where you go on site, you haven't seen a water mist system before. How do I verify its effectiveness? That was what was provided by the contractor. Did anybody spot anything on that would make you be concerned or would make you happy? Or
It's only 26 litres.
absolute brilliant spot, absolutely brilliant. If you go into a pub or a back of house kitchen, I'm sure you've all seen a little galley fryer with 2 little baskets in, yeah? That's what that's for. That's for a little galley fryer with 26 litres of oil that you'd use in a ship's galley. Well, that looks slightly different, doesn't it? But the contractor, shall we say, tried to provide the evidence to me, not knowing that I know a little bit about water mist. So, the said contractor went away and had a second go. Let's see how he did the second time round. Now, there's nothing wrong with this fire test data on there. It's perfectly valid fire test data from the Danish fire labs.
Very small though.
Sorry?
Quite small.
Yeah. So it's valid for what size of fryer?
1 by 3.
1 by 3. Can everyone see that on there? Yeah. So there's nothing wrong with our fire test data, but what I'm doing is I'm cross-mapping the fire test data with the actual physical application. Now it doesn't finish there. There's more. Okay? That said contractor has one more go. He gives me that. Anybody spot that? Anybody would like to have a look at that? I'm sorry the text isn't brilliant. I'll put you out your misery. It's for a machinery space on a ship. Okay, so 3 attempts to get it right, 3 failures. And this is a system that's been installed. So when it comes to water mist, be careful, do your homework, because these are things that are happening in the field right now to try and fool authorities having jurisdiction. Yeah.
What if there are no equivalent tests have been done? What you're saying is you can't extrapolate in any mode or manner.
No. If no tests have been done and evidence can't be provided, I would treat it as ineffective and it almost not being there.
Yeah.
And that has happened on multiple occasions. And so it might be a positive feature, but it's about providing that evidence.
Do you see the day coming soon where there would be an equivalent to an NFPA 13 for water mist?
I can't see it happening because each of the manufacturers have their own specific guidelines and test protocols, and most of the data they want to keep to themselves, quite rightly, because they've invested millions of euros in fire testing, so they won't share with other manufacturers, so there's no interchangeability between components. So I don't think we'll ever get to that point because each system is specific to that manufacturer.
Until they all start buying each other up.
Well, we'll see. I think this one's quite an interesting one. This is a land-based application for a college. And
Just before you go on, just a quick question. You
course.
got the documentation on 3 occasions, right?
yes,
You had done the inspection.
yes.
What was your recommendation?
The recommendation was to the underwriter was that we cannot have confidence in this system on site. And this is a food factory which is predominantly constructed of composite polystyrene panels. So we've got an additional risk of composite sandwich panels. And this is a fryer that sits in the middle of a factory with no compartmentation, with a high business interruption risk. And so our assessment changes on how we view that risk in that situation. So it's then left up to an insurance underwriter and our advice to make a decision whether they accept it, they may be, or don't accept it, and decide not to renew when it comes to renewal time.
Or maybe even say it's not the risk you told us it was, go find another insurer. Did that happen?
I think it's my understanding that particular premises is now undercover with someone else at the moment. So I personally don't have any more involvement with it, but I feel like I've done my job. I've gone through and been tenacious and checked it. So I feel confident I can sleep in my bed at night, knowing that this fryer is perhaps needs a bit more work.
Excuse me butting in, but just
No.
if the other insurer hasn't been given all the facts and there's a fire and there's an investigation and it turns out that they haven't been given all the facts, the claim won't be settled. That's the other thing, just that people need to be very careful about that and be very aware of that. With any fire protection or any material fact when
Yeah.
it comes to insurance and underwriting, the insurance underwriter must have an accurate picture of the risk that they're underwriting. If there's a large claim and it's investigated, there's a danger that if you're not, if the risk is different to what you've been told, you're going to wave two fingers at it, the claim won't be paid.
And I think also I do feel that it's a bit harsh on the client. The client's invested a lot of money in this system using a so-called competent installer, and quite rightly we have to have trust, don't we? If we have a plumber in our house or a gas fitter, we assume they've got the necessary credentials. So the customer's gone and spent all of this money and they're left with a system that the insurer won't recognise. So on a human level I can understand why the customer would have been upset by that. So let me just give you a land-based application. Yeah.
Sorry, just one question.
Yeah, of course.
Do you know if the plant owner had contracted directly with the installer, or had he been advised by M&E engineers or somebody to?
I think directly with the installer, yeah. I think he would have been advised by a previous insurer to get a water mist system for the fryer, and so they just went to market and got 3 quotes. Yeah. So the same process applies to a land-based application. This is a really good example of a school. So we're seeing more and more water mist systems being put into schools and hotels and offices. And this is perhaps a lesson just to be aware of. So we get the usual blurb in the documentation of about what it can do, what it's approved to, what's standard. But it's my role to pick that apart a bit. So I have picked it apart and picked up some red flags. It tells me it's an approved system to all relevant areas. What does relevant areas mean, and all relevant areas? Who decides that? It's fully compliant and it's been tested at the Building Research Establishment. Okay, there's some good stuff on there. Let's pick that apart a little bit further. Let's have a look further into the specification. BS 8489 has test data and occupancies for schools and classrooms. What's in a school? Just schools and classrooms?
Laboratories.
Laboratories? Gym stores? Yeah? Canopies? Kitchens? Atrium? So this particular water mist system has been fitted, even though it only has test protocols for one specific type of area within that school. Also, if you have a look down here in the permitted exceptions, there's a reason why that water mist system is considerably cheaper than a standard OH1 sprinkler system. For some reason, to make it cheaper than sprinklers, they've omitted all of the protection to the ceiling voids, which would be on a sprinkler system. Electrical rooms have been omitted, which are a key inception hazard in schools, should be protected. No protection to external balconies and canopies. Canopies are a key arson risk within schools, often used as external teaching spaces. So we sort of see how we're building a picture here of making something look better than it is and making it cheaper. But by digging a bit deeper, we can see the reason why it's cheaper and where it falls short of evidence.
But part of the issue here, though, is that the standard is not great.
Well, the standard is fine. The standard tells you what you can fit it in. So for me, if you haven't got test protocols for those other areas, it would lead me to say that you can't demonstrate it for those other areas. So perhaps in this case, water mist wasn't the right selection for that particular case. Yeah,
The
because
outcomes aren't equivalent.
No. So each occupancy, each area has to have independent fire test data. So the fire load in a gym store with all foam mattresses will be different from a school and university classroom. What about the roof voids? If we have a fire in a roof space which is not protected, that's going to go unseen and spread through the whole school. We'll lose the whole school. So there's some serious implications to picking and choosing exceptions within there. So it's important just to challenge these designs and have a look a little bit deeper. And by doing this, but this system's already gone in. So what do we do as insurers in this situation? So we've got a system where insufficient evidence has been supplied. It's only partial protection. It's only going to be there for life safety. It can only really be any more than a positive feature. The fire officer, the building control officer may be happy with it, but in reality in a school, the fire alarm's going to go off, everyone's going to be out in 4 and 5 minutes, and there is really no life risk. It's about a system being sold as a property protection system, when perhaps really in reality it's not. And let's pick that apart using our 4-stage methodology. We have the accredited test lab, we have the relevant standards, but we have no design installation manual for all of those areas I talked about, obstructions, beams, bays, and most importantly of all, we only have partial fire test data. At the time of analysis of that particular system, we had no component fire test data in which to fall back on. So this is where this quite simple process is really useful for you to dig a bit deeper below the surface, and actually what you see in a shiny specification, is it all it's really made out to be. So I'm conscious of time, so there's just 2 more slides I want to show you before we throw it open to the floor. And really these are the 2 most important slides of them all, really your takeaway. If you remember those 3 stages, those are critical for all forms of fixed fire protection. Can you verify for yourself that it's in service, it's designed right, and it will work? Those are the 3 fundamental questions you must be able to ask. And if you can't, it should lead you in some doubt as to the effectiveness of that system. And finally, if you want to check its design right, go through the 4 simple stage process, because this will lead you to the point in which you can make an informed decision, whether it's a residential block of flats, whether it's a school, whether it's an industrial oil cooker, whatever water mist project you come across and you want to verify it, this will get you to that point. Any questions? Thank you very much, by the way.
I don't know if we've a roving mic. Just
Yeah, I think there is. Oh yeah.
No, don't stand up because each put a second mic. I was stepping out to check to see
Any questions?
were there any questions from the online audience, and there isn't.
Oh, okay.
I think you've probably answered an awful lot. Kevin, I'll give you.
So any questions you like, just throw them out there.
Thanks.
Actually, I'll ask a question if you don't mind.
Yeah.
It's not so much directed at Gary, but at the people in the room here. Do many people are many people here aware of water mist systems in the Republic of Ireland? The only systems I've come across are in the likes of tunnel ovens and so on. Now, I've come across them in the UK, but not here. Anybody? Any comments there? Yeah. Go on.
Yeah, we have some time ago installed partial coverage in the pub, 2 pubs.
2 pubs, yeah.
Yeah, and in fact we used at the time, I think, plastic piping. Was it Flame Master?
The Blaze Master, yeah, which is
Blaze Master,
commonly
yeah.
used in in residential applications, yeah.
One was copper and the other was Blaze Master.
Yeah, so copper for your rising main and Blaze Master in the other area, yeah. Yeah. So yeah, so designed for a life safety type application, yeah.
My name is Arjun. I've seen one installed in National Library of Ireland, and that was a marry-off system.
Yeah.
And that's where it was used.
Yeah, we've got a couple of representatives from Marioff in the audience tonight, actually. So yeah, so I hope you checked the fire test data.
Oh, very.
Actually, to be fair to Marioff, they have got a vast array and history of fire test data. So if you challenge them, they should be able to provide that evidence to you.
Very good. Just another question on that. Which brands would you be considering as a good brand if you ever have to specify it to a customer?
Well, I work for a Swiss company, so I have a very independent frame of mind. So we as but seriously though, we have to remain independent. We won't, as an insurer, recommend any companies. So it's the job of the customer to present us with the information for us to validate it and see if it's acceptable for insurance purposes. So we remain totally independent of that procurement, buying, and we won't generally recommend companies. So sorry, I can't be any more help to you on that one.
Thanks.
Gary, I have another question. Do the Zurich underwriters give discounts in the same way as they might for, say, a sprinkler system in the case of water mist?
I think we perhaps have to look at sort of break that down into 2 halves. So for local application systems, for fryers, machinery spaces, they're there for a specific task. So there wouldn't be specific discounts, but it would affect our overall opinion and grading of the risk. Our qualitative risk assessment would improve with acceptable fixed fire protection. And in the terms of land-based applications, we've not got sprinkler equivalency yet, and so we've only got partial systems that are predominantly there for life safety. So at this stage, it's predominantly seen as a positive feature only.
Okay, thanks.
My name is John, and I have never come across a mist system before. Could you perhaps explain the concept behind it? I heard you talking about 100 bar as a feed pressure. Is it getting the same volume of particles, water particles, out because of the higher pressure compared to a sprinkler, or what is the actual theory behind the concept?
Yeah, so it depends. It's manufacturer specific. So some manufacturers provide low pressure systems, and some manufacturers provide high pressure systems. But ultimately, what they're both trying to achieve is a fine mist of sort of typically 0.01 micron size of mist particles. And so the main objective of the mist particles is to really deplete the oxygen, reduce the oxygen content within the space, provide rapid and effective cooling, and also to provide radiant heat blocking of the heat source. So it's a very effective fixed fire protection system. And as I say, all of the nozzles are independently verified and tested to provide very fine mist particles for the purposes of cooling, oxygen depletion, and radiant heat blocking.
Sorry, Gary, what is kind of seen typically the maximum compartment size that a water mist system can manage as such, or is there such a thing?
Will be limitations on that. So when a manufacturer goes to a test lab, what they will do in conjunction with the test lab is determine the size of the space in terms of the square meterage, and also, well, four key parameters really: the fire load within that space, the volume of the space, and the ceiling height, and also the pass-fail criteria. But the first three are really what you're looking at. So it will depend. So you can have, like, for example, for combustion turbines, you can have spaces of nearly 5,000 cubic meters of space. So it just depends on what's been agreed as your test protocol. So there is no hard and fast rules around that.
Sorry, Gary, quick question. Sorry, John Shear.
It's John Shield. Just the question I have, you've mentioned about schools. They're all light hazard or relatively light hazard. What's the heaviest hazard you've found? And I'm not talking about generator enclosures or stuff like that. You mentioned about the warehouse with the hanging garments. How heavy a risk have you found in your travels that is protected by a water mist suppression system?
So, for example, the schools are generally ordinary hazard 1, but they can be, some of the very large academies can actually be ordinary hazard 3. I have found inappropriately fitted water mist within a storage warehouse application with a 15-metre high ceiling, which would be totally ineffective. So generally speaking, in the land-based market, you're looking at most manufacturers are testing to the ordinary hazard 1 protocol. Some manufacturers are now doing some limited testing on ordinary hazard 3. So generally speaking, the rule of thumb is most of them, where they're specifying for schools and offices and hotels, would be an equivalency to ordinary hazard 1 fire load and occupancy.
Am I correct in assuming that the warehouse you came across with the water mist, you're no longer on cover?
I don't know whether we're on cover or not, but I did make an assessment to the underwriter that the system was ineffective and wouldn't be suitable for such a challenging, and effectively that is a high hazard fire load. And just to make perhaps complicate it further, it did have high bay racking, so we had racking to 10 meters, so that clearly was a roof and rack domain, sort of 7.5 10 millimeters density at roof, and in rack sprinkler protection every sort of 2.5 3 meters.
And were you guys involved in the initial conditioning of the system, or was that a previous insurer?
No, we weren't involved with that, and that's one of our challenges. We have a big team of risk engineers in the field, but we simply, we're insuring many customers, so we can't get round all of our customers to see all the systems we've got. So we do often, where we take on a new client, we will walk into a system which we've never seen before and have to make an assessment on that, and which can be challenging at times.
Gary, I just have 2 questions to put to you. Just one is related to the idea of a certified water supply. Here in Ireland, we've more or less privatised our water supply. It's not private, but it more or less is.
Okay.
And it's now provided by Irish Water, who've confirmed that they won't provide a certificate to certify that the water supply will achieve A, B, and C. And the second thing is the relative efficacy between a domestic sprinkler system and a water mist system that might do the same job. Currently, in Ireland, we would rely on the British standard for domestic sprinkler systems.
Yes.
So therefore, there is a coded design, installation, delivery system for domestic sprinklers. What about the same situation for water mist from your own experience relative to efficacy?
Yeah, so we're seeing in the market back home, we're seeing systems in the domestic market being installed to BS 8458, which would be looking at an alternative to residential sprinklers, and using that instead of residential sprinklers. And so they're typically off the town's main system or a boosted water supply. So that, from a life safety perspective, from a fire officer building control, that would be acceptable from a life safety perspective instead of residential sprinklers to BS 9251. So from that perspective, from a life safety perspective, I don't see any issues at all. It's not something insurers typically get involved with because, as I say, it's there for means of escape purposes. But a standard is there. The 8458 standard is there, and it serves that need that you were referencing. And water supplies are covered, and the requirements for water supplies are covered within that standard.
And the experience in relation to certified water supplies.
Yeah, I mean, back home we don't have really such things as certified water supplies, and it's a big challenge in many parts of the UK around what the water undertaker is supplying to that site. So sometimes, you know, the water supply just isn't sufficient in terms of pressure, and you're looking at some kind of boosted supply sometimes as well. From a commercial industrial point of view, from an insurer, we always recommend pump and tanks, because we've seen, especially in England, a reduction in Towns Mains pressures across many counties of England, which has impacted on Towns Mains system to provide the necessary pressures and flows. So it is something we would recommend against relying on the Towns Mains municipal supply.
Okay, thanks very much. Has anybody got any other questions?
You know, an oddball. You mentioned one of us in terms of fire suppression of a space or a piece of equipment.
Yes.
Have you ever come across it being used as in lieu of a firewall?
I have actually, yeah, I've actually come across that in lieu of a physical fire separation, I guess, of an hour or 2 hour wall. I have seen it in place. Again, there is no fire testing to support such application. I've seen it, and you have to take it on its merits when you see it, but there can never ever be any evidence to support that. So we would have to sort of think about that one very, very carefully. But yeah, I have seen it. I mean, that sort of covers the old-fashioned sprinkler cut-off head above a fire door, doesn't it? Or where a roller shutter goes through an aperture in a food factory, for example. It's trying to achieve the same objective, isn't it?
No, I've seen it, but I was kind of wondering what it was there for. I thought, actually, until tonight, but two together.
It's what, sorry?
It wasn't until this evening that I actually mentioned, but two together.
Yes, yeah, I have seen it being used, but from a property perspective, we would obviously put our faith in something that was a bit more robust than that.
Okay, I think we're not receiving any more questions from the audience. And I might just explain, if anybody online has tried to send questions in the meantime, there's a suppression system here to stop emails coming through and phone calls. So I haven't received anything since I've come back to the audience or to the theatre. So if there were any questions, apologies. We haven't been able to ask your questions. Just on our own behalf and on behalf of the division of Fire and Safety Division and Engineers Ireland, thank you very much.
Thank you very much.
They give a book, Engineers from DK.
Oh, thank you very much.
It's been a very interesting talk, very competent speaker, a very good technical talk, I thought, very informative, and I think anybody who will look back on the presentation on the webcast will find it very, very informative as well, and give us plenty of talk for when we go and have our Christmas dinner and discuss the activities over the last couple of months. We will have another talk in February. It's probably going to be on smoke control in tall buildings. That's yet to be confirmed. And that'll be on February the 15th will be the next talk here in the theatre. So until then, have a very happy Christmas. Safe journey home to you, Gary. And just like everybody, to give a show of hands to Gary to thank him for his talk.
Thank you.
Thank you. Good night, Karen.
Thank you.